Okay, so first thing, first you need to know what a prism is. Let's start there. Does anyone know what a prism is? That's a prison, but nice try. Here's the definition, okay? It's a polyhedron. So what does that mean? How many dimensions are we working in? 3, right? It's a 3-dimensional figure, polyhedron, with exactly, keyword, it's got to be exact, 2 congruent parallel faces. Okay, so you will always have 2 congruent parallel faces. We call those the bases. Sorry, my pen is not connecting very well right now. So 2 faces that will be congruent and parallel. So like if we look at my figures from before, okay? You know what I didn't write in here? Well, no, I said polyhedron. Never mind. So like this is a prism, right? You have a square here, a square here. They are parallel to each other and they are congruent to each other. That makes it a prism, okay? This one, you have a triangle here, a triangle here. They are parallel to each other. They are congruent to each other. That makes this a prism, okay? This one. This would be called a hexagonal prism. You have a hexagon and a hexagon with all these rectangles connecting them. That is a prism. Last one in here that is a prism is this guy. You have a triangle and a triangle. They're parallel to each other and congruent to each other. That makes this a prism. Okay, so these are all prisms up here. If you want to see a picture in the book of a better version of what I'm talking about, page 1592 in the book has pictures. We call these faces the bases. The other faces of the figure we call lateral faces. If you think of football, a lateral is often thrown to the side, right? It's backwards, but often they're not like turning around and throwing backwards. It's off to the side somewhat. So think the sides, the lateral faces. So that's not the bases, right? Here's my bases. My lateral faces then are these 4 rectangles on the side. And if you notice, they're all what shape, the lateral faces? They're all rectangles, okay? If it's oblique, then it's more of a parallelogram, okay? This would be considered oblique. Basically, oblique is if you have we would say this is a right prism when it stands perpendicular. My lateral faces to my base form a 90-degree angle. When it doesn't form a 90-degree angle, right? So this is not flat, not perpendicular. When I look at my lateral faces, we say this is oblique. It's kind of like they just took the whole figure and shoved it a little bit, and it is now on a bit of a tilt. But your height for that would still be the same as the height for all of these. These are all the same height, okay? Okay, we're going to talk 2 different formulas for a lot of different figures in this chapter. Today, we're just talking prisms, but we're going to talk about the lateral area. Okay, and we're going to talk about the surface area. When we talk lateral area, most of the time, it's just going to be written as LA. Okay, that's lateral area. And the lateral area of some figure is just the sum of the lateral faces. Okay, so for instance, if I took this hexagonal prism and I wanted to know the lateral area, I'm finding the area of these 6 rectangles that wrap around it. Okay, I'm not finding the bases, just the lateral area, so the ones that wrap around. Okay, so that's lateral area, but then there's also surface area. And surface area is always going to be SA. And that's the sum of the lateral area and the two bases. Okay, so in order to find surface area, you always have to find lateral area first. So in other words, in this figure, I can find my lateral area by finding the 6 rectangles that wrap around, and then I add this hexagon and I add this hexagon. Okay, that would be the surface area. So every surface of this would be the surface area. Okay. So I'm going to show you how they come up with surface area, and then I'm going to give you a formula so you don't have to do the whole net process every time. But we're going to start with a net just so you can see what we're working with. So example 1 here. Let's say we have a rectangular prism. So it's going to be a bunch of rectangles. This is 5. We're going to go 4, and then 3, and then 4, and then 3. Okay, and then a face up here and a face down here. Those would be our two bases. Okay, so this is still 4. This side is still 3. If I want to know the surface area of this figure, you always have this as an option. I can always just break it into all the figures making up the prism that we're talking about and add them all together. So if I'm looking at this as individual rectangles, what's the area of this rectangle? It's 12, right? It's 4 by 3. So 12 would be the area of that rectangle. Is there any other 12 rectangle on here? The other base, right? This is your first base. This one, 3 by 4, would be 12 also. Okay. What's the area of this rectangle? That would be 20. 5 by 4 or 20. Okay. How about the one next to it? That would be 5 by 3, so that's 15. The one next to it is a 5 by 4 again, so that's 20. And the one next to that is a 5 by 3 again, so it's 15. So I have found the area of 6 rectangles right now. So if I want the surface area, what do I have to do with that? Add it all together, right? You're going 12 plus 12 plus 20 plus 15 plus 20 plus 15. Okay, and when you add that all together, you get 94. Okay, another way you can think of it to simplify it is you have 2 20s and you have 2 15s. Okay, that's going to be our lateral area. So if you add those together, 40 plus 30 is 70. And then we have 2 12s that we're adding to it to get to our surface area. So when we add 24 to that 70, we get 94 as our surface area. Now that is a lot of work to have to draw out a net and to lay it all out and find every figure's area. It's just a lot of steps, okay? You're welcome to do it. I don't recommend it. You probably won't finish your quizzes and tests in time if you try to do it this way every time. But just know that if you get stuck on one, you always have this to fall back on, okay? It is just finding the area of each face of your figure and adding them all together. What we're going to do instead is we're going to come up with what formulas will get us there. So here it is for a prism, and I will put these on the board as well. My lateral area formula is PH. What do you suppose P stands for? Perimeter. Okay, now here's the deal. Probably just as important as the formula is you understanding what part each variable stands for. So P is not perimeter of the figure. It's the perimeter of the base. Okay, P is perimeter of the base. What do you suppose H is? height, okay? So h is the height, not of the base, it's the height of the figure, the whole figure. What is the height of the figure? Okay, so we're gonna be using those. Make sure that you write these down somewhere because you're gonna wanna refer back to them because it's easy to get them confused with other parts, okay? P is the perimeter of the base, H is the height of the figure, okay? Then, for the surface area formula, you're gonna take the lateral area and you're gonna add 2b to it. What do you suppose a capital B stands for? Base, okay? But again, write this down because you can't just say, oh, 2 times the base. What about the base? We have to find the area of the base. So when you see a capital B, you need to think area of the base. Okay? And then if you can do that, you can do these problems. So make sure you know what the variables stand for, and we're going to try a few to make sure that you've got it, okay? Here we go. Let's say this is, well, you tell me, what is the name of this figure? A triangular prism. Okay, while I'm thinking about it, don't draw this one necessarily. What's this one called? A triangular prism, okay? You name a prism by the shape of its base. So I feel like all the time I get people telling me this is a triangular prism, like they see it, but then when they try to tell me the area of the base, what do you suppose they're finding an area of? The rectangle, because it's the bottom of the figure. Okay, this is not the base. When it's laying on its side like that, you're still finding the area of the triangle. Okay, so just be really careful with that. If it's standing upright, people seem to get it, but as soon as it lays on its side, people start to find a different thing as the base. The base is always the two things that are parallel and congruent, okay? Okay. Get rid of that. Here's what we're gonna do. I'm gonna give you some dimensions. So this is a right angle. This is 3 centimeters on that side, 4 centimeters on this side, and 6 centimeters on this side. Okay, so we said this is a triangular prism, which means my base is what shape? The triangle, okay? Maybe write that down when you do a problem, just so you know you're finding the right area and the right perimeter. If I want to find the surface area, I have to start with the lateral area. So what's the formula for the lateral area of a prism? Perimeter times height, P times H, okay? P right now represents the perimeter of what? The base. What is my base? It's a triangle. So you're finding the perimeter of the triangle, okay? Now look at that triangle. How can I find that missing side? Pythagorean theorem, okay? If we call this C, it's 3 squared plus 4 squared equals C squared. What does C come out to? Most common Pythagorean triple there is 5. It's 3, 4, 5. So this comes out to 25 equals C squared. We square root it, so C is 5. Okay, so we're going to put that up here. So if I'm trying to find the perimeter of my base, what is it going to be? You need to do 3 plus 4 plus 5, right? So that's 12. Okay. Now H is a height of what? The triangle? The figure, right? The height of the figure. So H is always the distance between the two bases. What shape is my base right now? Triangle. So I want the distance between the two triangles. What is that? That's the 6, okay? This right here is the height of the figure, so 6. So my lateral area is 12 times 6, or 72 square centimeters. Okay? How we doing so far? Okay, so now if I want the surface area, the formula for that is lateral area plus 2 times the area of the base. What is LA? 72, right? You already found that one. That's this one. So you're just going to drop that in here, 72 plus 2, and then times the area of the base. Ryan, put that away. How do you find the area of the base? Times a half, right? 1/2 base times height. So here's the deal. Your base is a triangle. So that's 1/2 base times height. Here's where this stuff gets a little bit much, okay? You have a capital B, but that capital B is 1/2 lowercase b h, okay? This h is not the same as that h. So there's just a lot going on in these. You gotta make sure you take it one little step at a time, and then it's fine. But if you let yourself get overwhelmed by a bunch of letters, it's hard, okay? So take it one little letter at a time, and it's just fine. So if I'm doing 1/2 times the base times the height, it's 1/2. What are the base and height of the triangle? 3 and 4, right? Your triangle has a base and a height of 3 and 4. So 1/2 times 3 times 4 is going to give you, so this whole thing right here is your capital B. Okay? So if we simplify that, we get a surface area of 72 plus 2 times 1/2 times 3 times 4 is 6. Okay, so the area of the base is 6. We need to multiply that by 2. So 72 plus 12, which means we have a surface area of 84 square centimeters. Okay? Questions on that? Okay, when you see a P, what does it stand for? Of the base, the perimeter of the base. When you see an H next to a P, what does it stand for? Height of the figure, okay? But then if you see other H's, it's the height of the base when you're looking for the area of the base, okay? Capital B is the area of the base. Okay, one more, and then we're done. Yes. Let's say, can you name this figure for me? Hexagonal prism, okay? So we're gonna mark all of these congruent. So it is a regular hexagonal prism. This is 6 meters. And then this length here is 12 meters, okay? So start with the formula. Lateral area is the perimeter of the base times the height of the figure. What is our base right now? What shape? It's a hexagon. So what is P? 6 times 6. You have a hexagon. 6 times 6 will get you the distance around that hexagon. So 6 times 6 is P. Okay? What is H? It's the 12. It's the distance between the two bases. Okay? So your lateral area right now is 36 times 12, which is 432 square meters. How are we doing so far? Good? Okay. Then we want surface area, And surface area is your lateral area plus 2 times the area of the base. Hopefully finding the area of a regular polygon is second nature to you by now, because we've done it in 3 chapters now. Well, we've done stuff with it in 3 chapters, not necessarily found the area. So if I'm going to start with lateral area, that's going to go here. Okay, so 432 plus 2 times B. What is B? Area of the base, which is a regular polygon. So really what you're going to plug in here is 1/2 AP, right? Area of a regular polygon. Okay, so let's look at this hexagon in light of that. I know this is 6. I need an apothem and the perimeter. Now, the perimeter we already have, right? This P here is this P here. So the perimeter is 36. Okay, we know we're going to put a 36 here. We just need to figure out what is that apothem. Right, so if this piece here is 3, remember this is a 30, 60, 90 every single time in a hexagon. And again, if you don't remember that, then you just have to do 360 divided by 6 and cut that in half to get your 30-degree angle. Okay, so you have a 30-degree angle, and in a 30, 60, 90, this longer leg is your L rad 3 side. So that A is 3 rad 3, okay? So let's just plug this in. You have an apothem of 3 rad 3, okay? So it's gonna be 432 plus 2 times 1/2 times 3 rad 3 times 36. It's a lot going on there, right? One thing at a time. Okay, so if we simplify 2 times 1/2 times 3 rad 3 times 36, you get, so this comes out to 108 rad 3. Plus 432. If they ask you for an exact answer, that is your exact answer. Why can't I simplify that any further? It's the radical, right? It's not, they're not like terms right now. So you can't combine a radical with a non-radical number. So we would say it is this many square meters, okay? Most of the time on these, they don't ask you to leave it like that. They'll just say, find it to the nearest tenth. So 432 plus 108 rad 3 comes out to a surface area of approximately 619.1 square meters. It's a lot of steps. Okay. Questions on that? Okay, here's the good news. This is what you're doing today. Tomorrow, you're doing this exact same thing with a cylinder instead. So the only difference now is your base is a circle. What's the area of a circle? Pi r squared. What's the circumference of a circle? Pi d, okay? So you're gonna use pi instead tomorrow, but it's the exact same process, okay?